Bismillahirrahmanirrahim. Inshallah, today I will talk about simplifying radical expressions. First, we have to understand what that means. When we say radical, as we talked about before, that refers to basically taking square root of stuff and things. And for example, square root of 16 is 4. Okay, so one way of thinking about radicals is like square roots. But square root is actually only one form of radicals, and we will appreciate that shortly. But it's a good start. So radical expressions are, for example, something like this. 16x squared. Okay, it's a radical expression. This over here, 16x squared equals 4. This is a equation. So this is a radical expression, and this is a radical equation. And if you had this would be a radical function. So this is a radical expression, radical equation, and radical function. Today we should be dealing with expressions. That means there's nothing to solve or anything. The primary is to simplify. So simplifying radical expressions, like, okay, if you have a fraction like 4 over 8, I mean, that's not the most simplified form of this fraction, right? You could change this to 1 over 2. So it's just like you're simplifying fractions, you can similarly simplify radical expressions. So that's what it means to simplify radical expressions. This tends to be, curiously, sometimes a difficult topic for kids, and it's like, teach them, you forget, they teach them, you forget, teach them, you forget. So I'm going to not rush this and try to explain it to you the best I can, so hopefully it'll stick, inshallah. So the first thing you have to understand, what does it mean when you say like square root of 25? Okay, now you know the square root of 25 is 5, right? So, but what does it mean to have a square root? What does this symbol mean? So this is just a symbol. Somebody could have said, you know, instead of using this symbol, they could have invented, I don't know, they could have invented this symbol. And then this squiggly thing of 25 would be like 5. You know, it's just a symbol that was invented to express a certain thought. So what thought is it that they're trying to express when somebody says square root of 25? And when we say square root of 25, actually, there is a number that's invisible over here that we don't write, and that is 2. Okay, so this is the second, the square root of 25 can be written as that. In other words, these two expressions are the same. Okay, square root of 25 can also be written with a 2 over here. All right, so so square root of 25 is 5, means that what two numbers, when you multiply together, will give you 5. Okay, what two numbers, when you multiply together, will give you 5, and that is, of course, 5 and 5. So 5 times 5 gives you 25. So the square root of 25 is 5. Okay. So that's what it means when you say square root of 16. It means what two numbers, there's a 2 over there when you're taking this square root, what two numbers, when they multiply together, give you 16. Well, 4 times 4 is 16, therefore square root of 16 is 4. Okay? Now, then you say square root of 15. Now this is going to be irrational because, as you know, this 15 is not a perfect square. Now, square root of 15 is what two numbers, when you multiply together, will give you 15. Well, let's see if we could do square root of 15. It's an irrational number, 3.8729, blah, blah, blah. So it's 3.8729, dot, dot, dot. So it goes to infinity. So if you take 3.87, blah, 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 times 3.8729, dot, 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 will give you that. Okay? So that's the idea of a square root. Now, another way of expressing this is like this, okay? Very simplistic. If I have a square root of two numbers, like 5 times 5, that's 25, right? If I have 2 of something inside of a square root, they come out as like 1, 5. Okay? In other words, if you have something like this, okay, what's this? This is cute. If you have, like, you know, 2 happy faces like that, okay, those 2 happy faces, okay, will come out as 1 happy face, like this. Okay, so this is really actually very important. If you understand this, if you have 2 of something inside, okay, they will come out as 1. That's the key. Right? Now let's do this. I like the happy face analogy. Okay, let's try that some more of it. Okay, let's say you have 3 happy faces inside. I'm not going to draw the happy faces. Maybe I will. I don't know. Watch this. Now you have 3 happy faces. See? Now the 3 happy faces, all right. Ooh, what happened to the happy faces? Okay, watch. So the 3 happy faces, okay, see, 2 of them will come out. These 2, they will come out as 1, and this poor guy will be left inside. He's happy inside too. He likes indoors. Okay, so let's make him happy too. He likes it indoors. So 2 of them come out as 1. So when these 2 come out, these 2 come out as 1, and there's 1 happy face still. This guy's still left inside. Okay, so if you understand this, then you can do most all of these simplifying radical equations. So for example, if you have 2 of these, whatever those green thingies are, they both will come out, right? And you have, like, the answer to that is this. And if you have something like this, 3 of these green thingies, okay, 2 of them will come out as 1, and then that will be over here, and then inside this other one will still be left inside, like this. Okay, all right, so let's see if we can apply this. So now you have over here, see, square root of 8. Now square root of 8 is not a perfect square. So if you take the square root of 8, you get an irrational number. So let's take the square root of 8, see? So you don't want that, you can do that and calc will give it an irrational number, but there is no square root of 8. But you can see square root of 8 is 4 times 2, isn't it? Correct? 4 times 2. So you can rewrite the square root of 8 as 4 times 2. Okay? You can do this because there's a rule which we will talk about in a second. Now 4 times 2 is 8, right? Now 4 is a perfect square. That's 2 times 2, square root of 4. So this will come out as 2, and this 2 will remain inside, and that'll be a 2. Okay? You understand? So square root of 8 simplifies to 2 times square root of 2, because 8 is 4 times 2, and this can come out as square root of 2, as 2. Okay? Now, let's do another one. Here is 27. Okay? All right. Before I do this, I should just relate to this rule, okay? Now, square root of a times b, this is kind of an important rule. This is what allows us to do everything we're doing over here. Square root of a times b is square root of a times square root of b. Now, you see when I write square root signs, I'm very used to writing this little hook thing in the end. That's not by accident. I'm so used to it. It's just for emphasis. It tells you the square root sign goes up to over here. and so that there's no confusion. Let's say if I wanted to write something like square root of 3 times x to the 5th y. Now here, for emphasis, I'm saying this is the end of the square root. This is not part of the square root. So if somebody doesn't imagine that I'm saying, like, square root of 3x to the 5th y or something like that. So this is just for emphasis to suggest that that's where the square root sign ends. Okay, so this is a very important rule. Square root of a times b is square root of a times square root of b, like this. And the converse of this, okay, if you have square root of a times the square root of b, you can combine those two and until you get ab. In other words, if you have two things under the one roof, they can separate into two separate square roots. And if you have two squares, and if there's a multiplication inside, like that, then they can come under the same roof, okay, so to speak. But if it's addition, you can't do that. It's only when they're being multiplied, okay? All right. So let's simplify some more. Now I have square root of 27, okay? Now square root of 27, it's not a perfect, it's not even nice number, it's irrational number, but it's 9 times 3, right? And that's 3 times 3, correct? All right? Let me do it this way. 3 times 9, and 9 is 3 times 3, correct? So this is the simple, this is like factored out 27. It's 3 times 3 times 3, okay? So two of these will come out as 1, and this 3 will remain inside. So these 3 will be here, and this 3 will be inside like this. So 27 is 3 square root of 3. Another way of doing that is 27 is square root of 9 times 3, and this is square root of 9 times square root of 3. Square root of 9 is 3, and the square root of 3 like this. Okay? Let's do another example. Here's square root of 50. Now square root of 50 is 25 times 2, right? Okay. Right? Now 25 is a perfect square. You can take the square root of 25. It's 5 times 5. Okay? So you can rewrite this, if you like, as 25 times 2, like this, right? 25 times 2. And the square root of 25 is 5, so that comes out 5 times square root of 2. Okay? Now, let's do this. Now I have square root of 50 times x squared. In this case, I have a variable and a number here under the radical sign. This is called the radicand, if you like. Everything that's under the radical sign is called a radicand. C-A-N-D as in candy, radical candy. So radicand. So now you can simplify this. You can take one at a time. So 50 is 25 and times 2. Okay, now this comes out back because that's a perfect square. It's 5 times 5. So that becomes 5, and the 2 stays inside there, 2. And then the x, see, square root of x squared. Now remember the happy, if you had the happy faces, one of them comes out, right, like that. So 2 of them will come out as 1, so this is x. So square root of 50x squared simplifies to 5x times the square root of 2. Okay? Okay, let's do some more. This will do a lot of examples so you can get this. Alright, let's try this simple one. 4x. Okay, everything, this is the radicand is the 4x here. Okay. Now square root of 4, okay, now you can remember the square root of a times b equals square root of a times square root of b. Okay. So you can separate these out. And you can say, well, this is square root of 4 times square root of x. Okay. Well, that is square root of 4 is 2 and times square root of x. So this simplifies to that. Okay. Another way of doing the same thing is just say the square root of 4x. See? Now you can take this and just bring it out as 2 because square root of 4 is 2 and then 4 remains inside as that. Okay. So you can kind of do this in your mind, so to speak. You can, okay, separate them out. Okay. Let's keep doing some more examples. How about this one? Square root of 32. Can we simplify this any? What goes into 32? Okay, well, 32 is 16 times 2, 16 is a perfect square, right? That's 4 times 4, okay? And so you can rewrite this as 16 times 2 if you want to. And then you can say, well, 16 will come out as a 4. And then this 2 will remain inside 2. So square root of 32 can be simplified to 4 square root of 2. Okay? Alright, let's do another one. These examples I'm getting from your textbook. Let's do 9x cubed. Well, the square root of 9, this just comes out as perfect square. That comes out as a 3. Alright, I'm going to just write this for convenience. Now, x cubed, that's x times x times x, right? So 2 of them can come out as a pair. That will go over here. Okay? But this guy will stay inside, so x. Right? So this would be the simplest form of this, right? 3x times square root of x. Okay? Now let's keep going. Let's do some more. How about just square root of 24x to the 5th? Okay, let's try this one. Well, 24 is 4 times 6. 6 times 4 is 24. And this goes in 3 and 2, but that's not going to help us because, okay. And x to the 5th. So 4 can come out, right? This square root of 4 is 2. And then you have you have x to the 5th. You have 5 x's, okay? So when you have x to the 5th, right, it's like 2, 3, 4, 5. See, 2 of them will come out as a pair, okay? So this will come out as an x, and that will come out as an x, so it'll be x squared, all right? So it'll be x squared on the outside, and this 1x will remain inside like this, okay? And then the 6 here, okay, like this, okay? So let me do the same example again, so you make sure you get this. So 24 is, okay, 4 times 6, 6 times 4 is 24, and so this 4 can come out, like, okay, so it'll be 2, and, oopsie daisy, so this is like this, and the 6 will remain inside, and x to the 5th, okay, so that's like x to the 4 times x, right? So this will come out as 2 of them, each pair comes out. Each pair will come out like x to the 2nd, and 1x will remain like this, okay? So this will simplify to this, okay? How about this one? Square root of 25x squared. Well, square root of 25 is 5. Funny looking 5. 5. And square root of x squared. What's the square root of x squared? There's 2 of them. That's just x. So square root of x squared, that's x. So this whole thing simplifies to that. Okay. Alright, how about this one? Square root of 6 times the square root of 6. So you can't simplify 6, right? That's 3 times 2, and that thing comes out, right? But here you can bring these two together. See, my computer is a little acting up here. Sometimes it does it. There's something on the, like a little thing, some dust or something. Alright, I'm sorry, let's start over. Square root of 6 times the square root of 6. Okay? So now see, you can combine these two together, okay? And they will be square root of 6 times 6, okay? Alright. So that's 36. Right? And square root of 36 is 6, so you can just say there's 2 of them, one of them will come out as 1. So here we combine these two together, and then that's helped us simplify it, okay? And now, how about this one? Square root of 3x times 4 times the square root of x. Okay, now you have to be careful here, okay? You have to be a little bit careful here. And now you can combine these as well, see? Now, there's 1 times this over here, so, okay? So this will become 4 times, you can combine these two under one roof, so to speak. Okay, that will be 3x times x. Okay, that's because if you have square root of a times the square root of b, you can bring them together in one big happy family like this, a times b, and it goes back with converse too, right? So now here we took two radicals and we combine them together, and this 4 is on the outside, so it will remain on the outside. Okay, so now we have 4 times square root of 3 x squared, right? But x squared, or these two can just come out as 1, so this becomes 4x times the square root of 3. So this will simplify to that. All right? Okay, how about this one? Okay, this is square root of 7xy squared times 3 times the square root of x. Let's do this. Now we're getting better at this now, Joe. So we can bring everything under the same roof. Okay, nice big, give yourself lots of room. And, well, all of this and all of this, we'll just put them together. Just put them together first. Alright, like that. Okay? And then you can simplify them. So 3 times square root of 7. Now x times x is x squared, and then y squared. But now you see this x squared will can come out as 1 because there's 2 of them. They can come out as 1. And the same thing with y squared. It can come out as 1. So you can simplify this as 3 times x, and then times y times the square root of 7. Okay? So that will simplify to this. Oops, I'm sorry, I meant to say square root of 7 over here. Okay? So that's that. So what we've learned here is basically manipulating this single rule and a times the square root of b, and if you have square root of a times the square root of b, you can bring them together like a, b. And we have simplified fractions using these two properties of fraction of radicals. We have simplified. Okay, now there's another important property of radicals that we need to know. And that is this. If you have square root of a over b, you can simplify this as square root of a over square root of b. And vice versa. If you have square root of a over square root of b, you can simplify, you can rewrite this as a over b. It's helpful sometimes to do these in the process of simplifying. Okay? So let's take some examples. Now I have square root of 16 over 25. Okay, well this is square root of 16 over square root of 25. Well, this is going to be 4 over 5. Alright, how about this? Square root of 15 over 25. You can rewrite this as square root of 15 over square root of 25. Okay, now that's 15 you can't simplify, but 25 you can. So it'll be this. Okay, like that. Okay. How about this one? Square root of 13 over 100. Well, this is square root of 13 over square root of 100. Square root of 13, you can't simplify that, but square root of 100 is 10, and there we go. Alright, how about this one? Square root of 7 over x squared. Okay, well, that is square root of 7 over square root of x squared. Tough luck simplifying the square root of 7. It doesn't. The square root of x squared, however, is x. Okay. Alright. Now, let me tell you something. It is mathematical good manners to not have radicals in the denominator. In other words, it's bad manners mathematically, so to speak. Of course, I'm kidding. It's not like manners. It's not preferred to have radicals in the denominator. Okay, it's mathematical bad manners, so to speak. So when you have radicals in the denominator, you want to manipulate stuff to not have them in the. Well, how are we going to get rid of it? You can't just like erase it. You know what I'm saying? You got one of these numbers. You can't like, okay, there's no radical there. No, you can't do that. So you want to be able to get rid of this radical. What you do is this, okay? You multiply the top and the numerator and the denominator by this, okay, whatever the radical is. Okay, then simplify. And this becomes 5 times square root of 7, and square root of 7 times square root of 7. Now look at square root of 7 times square root of 7, okay? That is square root of 7, square root of 7 times 7. Okay, that these two come out as 1, that is 7, or you can say square root of 49, which is 7, right? So anytime you have two, it can come out like that. See, now this is something you have to know. Square root of 7 times square root of 7 is just 7. That's how you're getting rid of it. Square root of x times square root of x, okay, is x. Okay. This you have to know, right? Because 7 times 7 is 49, and the square root of 49 is 7. But that's how you're getting rid of the radical. Square root of x times square root of x is x. Okay? So see, now you don't have any radicals in the denominator. This process of getting rid of radical from the denominator is called rationalizing the denominator. Rationalizing the denominators, also known as just getting rid of the radical from the denominator, also known as having good manners in mathematics, so to speak. Okay, but this is called getting rid of the denominator, the radical from the denominator, or rationalizing the denominator. Okay, let's do some more examples. So let's do some more rationalizing. So here's square root of 2 divided by square root of 3b. Now we have to get rid of this radical. Okay, now what are we going to do? Well, we're going to multiply the numerator and the denominator by the same thing. So 3b, like this. So what do we get in the top? Well, you get square root of 2 times the square root of 3b over 3b, because that's what you're doing. You're doing this to get rid of the radical. You just left with 3b over here. Okay? Okay. And then you can simplify this. You can bring them in the same umbrella. Say that becomes 6b over 3b. Okay? And that's how you like this to be. You like to not have the radicals in the denominator. Okay? Now look. If I have x plus x, what is this? Well, that's 2x. If I have x plus 3x, what is this? That is 4x. Okay, now what if I have square root of 7 plus square root of 7? What is this? Well, that's 2 square root of 7. Because, x could have been square root of 7. Square root of 7 is a legitimate, honest-to-God number, right? It's irrational, yeah, but it's the number still, right? So 1x plus 1x gives you 2x. 1 over 7, square root of 7, and 1 over square root of 7 give you 2 square root of 7. If you have square root of 7 plus 3 square root of 7, what is this? We have 1 times this, okay? 3 times this will give you 4 square root of 7, okay? Now, so square root of 7 plus square root of 7 is not like square root of 49 or something like that. It's not that, because it's not multiplication, it's addition over here, okay? 1 apple plus 1 apple will give you 2 apples. 1 apple plus 3 apples will give you 4 apples, okay? When you're adding or subtracting radicals, okay? You add the numbers that are in front of her like that. Okay, now watch this. Okay. Now, square root of 7 plus 3 square root of 7, we said. Okay, one of this plus 3 of these, that'll give you 4 square root of 7. Okay, square root of 7 minus 3 square root of 7. Okay, it's not multiplication. There's not bringing everything in the roof or nothing like that. That's for multiplication. So 1 of these minus 3 of these, you get negative 2 square root of 7. Okay? You follow? How about this? The square root of 7 plus square root of 5. What is this? Well, that's square root of 7 plus square root of 5. You can't simplify that because it's like apples and oranges. It's like x plus y. Well, x plus y is just x plus y. You can't add those together. They're different numbers, right? You can't do it. So you can only add and subtract this if the radicals are the same. They're the same, okay? So let's do some examples from these, all right? So square root of 4, this is from the book, 4 square root of 10 plus square root of 13 minus 9 square root of 10. Okay, now here, see, you can combine these and these because they have the same radical, and they're like, you know, like terms of radicals, so to speak. Okay, you can combine them, and this is different, so you can't combine them. So 4 minus 9, what is that? So it's negative 5 square root of 10, and then plus square root of 13. That's it. Got it? Okay. How about this one? Let's do this one. 5 square root of 3 plus square root of 48. Well, there's nothing to do here, right? Because they're different. Yeah, that's true. But maybe you can simplify this 48, square root of 48. Well, I don't know. Let's see. 4 that into 12, right? Okay, 12 goes there. But 12 can also is 4 times 3, right? Okay, so let's try to do this. So I'm just rewriting this. 5 square root of 3 plus, okay, so it's 4 times 4 times 3. That's what, these are the factors of 48, okay? So these 4 can come out as 1. So that's 4 square root of 3, okay? Because in other words, you can rewrite 4 square root of 48 as 4 times 4 times 3. And these can come out as 1. Okay, so these come out. Okay, so, but now look what you have. You have 5 square root of 3 plus 4 square. Oh, wait a minute, I can simplify this because it's like apples and apples. So 5 plus 4 is 9 square root of 3. Okay, so this whole thing simplifies to 9 square root of 3. Okay, all right, how are we doing? Alright, I'm going to do a couple more examples here, okay? I gotta make sure you get this. You have to make sure you get this. How about this one? 1 over square root of x. Now, here you want to like simplify. You want to rationalize the denominator, which means clean up the denominator, put it in mustahab form, in desirable form, have good manners, don't put radicals in the denominator, okay? So you have to get rid of this radical. How are you going to do that? Erase it? No, we don't. Okay, multiply the bottom and top by square root of x. That's right, very good. So you do that, okay? So then the numerator becomes square root of x. Denominator becomes square root of x times square root of x is, yeah, x. Very good. So that's why you, so this is how you rationalize the denominator, okay? Let's do another one. How about this one? 2 square root of 7 plus 3 times square root of 63. Well, I can't add them, not yet at least. Can't simplify that. Maybe I can simplify the 63. Well, 63 is, well, that's 3 times 21. But 21 is 3 times 7. Okay, now this is it. So these are the factors of 63. Now, I noticed that in those factors, I have a 3 and I have a 3. Those can come out as 1. Okay, let me rewrite this whole thing first. 2 square root of 7 is 3 times square root of, in other words, you can write 63 as 3 times 3 times 7. And these two 3's, they can come out as 1. Okay, so then you have 2 square root of 7 plus 3 times square root of 7. These come out as one of these. That's that right there. So then that's 2 square root of 7 plus 3 times 3 is 9 square root of 7. Well, 2 square root of 7 plus 9 square root of 7 is 11 square root of 7, last time I checked. Okay, that's how you simplify radicals. Okay, one more example, inshallah. That's it for this section. Now here's another expression that we would like to be simplified. Okay, what are we going to do over here? Maybe I can distribute this. Okay, well, let's distribute it. So this becomes 4 square root of 5. Notice I wrote 4 square root of 5. I didn't write 5 to the square root of 4. Although that's correct, because that can cause confusion. People might think it's like that, right? If you're not careful, right? So it's better to write the number first and the radical second, so there's no confusion. So 5 times square root of 4 is 4 times square root of 5. Okay, now this becomes square root of 5 times the square root of 20. Okay? Okay, so this is 4 times square root of 5 minus square root of 5 times 20. You can bring them under the same roof, same radical sign. Okay, so 4 square root of 5 minus 5 times 20 is 100. So this becomes 4 square root of 5 square root of 100 is 10. So this simplifies to this. Okay, so what did we learn here in summary? We learned the following rules. Square root of a times b is square root of a times square root of b. Okay, and you can use this to simplify a lot of radicals. For example, square root of 50 can be rewritten as square root of 25 times 2, which can be rewritten as square root of 25 times square root of 2, and square root of 25 is 5 square root of 2, using this rule over here. Okay? And then the converse of this rule, also true, square root of a times square root of b. You can bring them all together and make a happy family like this. Okay? And then we learn that square root of a over b is also a, square root of a over square root of b, and the converse, square root of a over square root of b, can be rewritten as square root of a over b. Sometimes it's helpful to do this, sometimes it's helpful to do that. Okay, and then we suggested that it is not desirable to have radical signs in the denominator, so when we can, we try to rationalize the denominator and bring so that there is no radicals in the denominator. Inshallah, next time we will elaborate on this and we'll continue with chapter 11. Until then, wassalatu wassalamu ala rasulillah walhamdulillahi rabbil alameen. Assalamu alaikum.